Alright, in this tutorial we are going to begin radical expressions and starting with simplifying radical expressions. So a type of radical is a square root. This is going to be the most common radical expression that you're going to see in this unit. And a square root is just simply finding a number that will get squared to get the number underneath your radical symbol. So when we were solving for linear equations and we were thinking of opposite or inverse operations like addition is opposite with subtraction, multiplication is opposite of division. Squaring something is the opposite of taking the square root of that thing. So if you're trying to find the square root of a number or of a term, you're going to try and think of a number that can multiply times itself that will give you that number underneath the radical symbol. And that's going to help if you think backwards of understanding what your list of common perfect squares are. Now, I've said this before in a previous video, but just to kind of reiterate, the most important common perfect squares are numbers that when squared 1 through 12 give you the following numbers. 1 squared is 1, 2 squared is 2, or 2 squared is 4, 3 squared is 9, then 16, 25, 36, 49, 64, 81, 100, 121, and 149. There are infinite number of perfect squares, but these are just the common ones that you need to be very, very familiar with to make your life so much easier when simplifying these radical expressions. So if you cannot take a number of any of these, and you don't end up with a whole number, or you cannot have its square root taken, then you must factor that number in order to find a perfect square. So both of these examples that I'm going to show you today are examples on where the number underneath your radical symbol is not a perfect square. So this first one, the radical expression is 10 times the square root of 245. Now, putting these numbers in parentheses to kind of show you, since my radical symbol does not go all the way, that is the beginning and the ending of your radical symbol. So 10 is off by itself. We're going to leave that be. 245 is not a perfect square. When you take the square root of it, you do not get a whole number. So we need to find our factor pairs, and we need to determine which one is the largest perfect square. That is what our goal is. We're trying to find the biggest number in our t-chart where we get a perfect square. So 245. 5 is a factor times 49. 7 is a factor times 35. Now this one's pretty easy. There's only one number that is a perfect square, and it's this 49. So we're going to split up our number 245 into the square root of 49 times the square root of 5. Now I'm writing the perfect square first, and you'll see what I mean when I do the next step, because you're going to end up with a whole number and you want to multiply that with the other whole number. So we still have our 10 out in front. The square root of 49 is 7. That becomes our whole number, and the 5 just keeps right there because that's all that we can do. Then we combine like terms with our 10 times 7 to get 70 times the square root of 5. So a lot of these examples, you're going to still have a radical symbol in your final simplified expression, but you're just trying to take as much of the numbers out of your radical symbol by factoring to find your biggest perfect squares. So let's do the same thing with 45. Factors of 45. We've got 5 times 9, and that's our perfect square right there. 9 is a perfect square. So we've got the square root of 9 times the square root of 5. Square root of 9 becomes 3 times the square root of 5. Now you always want to write your radical symbol last, and all of your whole numbers and your constants go in front. It's just easier to read, so that way we don't have to kind of decide, oh, where does my radical symbol start, where does it end, where does the next number pick back up. If you just keep it at the end, then we know that there's going to be nothing after that radical symbol that's going to be included.